Hi, I'm Tommy Fernqvist with the ICPC Analytics. I'm here to tell you about problem D, clock breaking. So imagine that you are manufacturing clocks and that you are using these standard 7-segment LCD things to represent numbers. So we can represent 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 using this 7-segment LCD. And we also have these smaller segments to represent a colon, because what we want to do is really to build a clock. So we want to be able to represent time. So let's say that we want to define midnight as 0:00, and the minute right before is 23:59. Now, it turns out that these segments could be faulty, so they could either be burnt out, meaning that they're permanently off, or they could be burnt in, meaning that they're permanently on, or they could be working. So what we're supposed to do here is that given a number of consecutive minutes that a certain clock is displaying, determine which of these segments are working, are burnt in, or burnt out. And what we're given, so we're given text really, so either we have a dot or for a segment part that's off or not really part of our display, or we have an X saying that something here is on. So we're given this 7:21 display. So this is sort of representing 1 minute in time, and then we're given between 1 of these and 100 of these, and they're supposed to be consecutive. And our task then is to try to see whether each of these segments are working or not. And this is one of the easiest problems in the set. It's probably not as easy as sealing because it's a bit harder to code. There's a lot of details here, so the solution is sort of a bit longer, but really what you can do is take each possible starting point, starting minute, and then just check these consecutive minutes that you're given to see if they're consistent or not. So it might be that it's impossible to have these the segments that we're given as well. So for example, what we know here is that these colons, they are supposed to be on at all times. So here we see that one of the colon segments is on while one is off. So depending on what we are given, so if we look at the next display, if on all of these minutes that we're given, let's say that this top colon segment is always on, then we don't really know if it's working or if it's burnt in. And the same, I mean, so depending on, and this is off, obviously. Okay, and the same type of reasoning you could do for, say, this segment, but then you sort of have to have some idea about, okay, what number is this part of the display corresponding to? So it sort of looks like it could be 0. I mean, if these are working, this could be 0, and if this is working. But we don't really know yet. So we need more information to be able to discern which of these cases that really is occurring here. But there's nothing really tricky here algorithmically, so we expect a lot of teams to solve this, but it is a bit harder to code. And the sort of interesting cases are if you have, say that you have 9:59 or something here, and then the next minute is 10:10:00. So then it's sort of interesting to exercise to be able to detect that this rollover is happening. So maybe that's the tricky cases.